Hello, I'm Michael Shen, and my research concerns is titled "There is Science Behind Engagement Within Science Courses." To begin, what first initiated interest within this study is the analysis of the effect of the early morning science classes on student engagement, in which this research regarded low performance, participation, and focus of students for the lectures of various college science courses during this time frame. From there, the research developed into understanding the different teaching methodologies and its effect on student engagement. As found from various sources of literature, we can see a divide between the beneficial effects of an active learning pedagogy, which entails different teaching methods to basically apply the learning, more or less force participation and involvement among students, as well as focus on problem solving and conceptually understand the material. In short, this essentially results in greater retention and understanding of the material, which requires students to be more engaged in the class, compared to a traditional standard passive pedagogy lecture, in which an instructor reads off material for students to sit and hopefully absorb the material. And now for the sort of so what. Why is this important? Well, here at NSU, we have a predominantly science major population with a multitude of pre-graduate health programs. The science courses that these students take are dense with information that they have to retain for most likely their lifetime. And for most of them in programs, as myself, it's accelerated. So what I desire to look into comes down to my question of research, which is, what is the most effective teaching pedagogy within science courses at NSU, and what methods can be employed to make courses more efficient in promoting engagement and understanding? My overall thesis for this research is that the active learning pedagogy should be utilized within college-level science courses due to its effectiveness and its methodology in engaging students and promoting their focus and retention of materials within the class. So the literature which I reviewed basically synthesized three main ideas, the first being the correlation between engagement and performance, the overall effect on cognitive and behavioral function. Here we find that biologically, the brain naturally learns through applicational methods such as problem solving, which strengthens neural pathways in regards to retention and memory. Incentives and motivation also play a role. Group work and other activities provide opportunity to increase grades through engagement. Also, a neat point to mention is that active learning often makes students aware of how much they actually know due to the focus of the methodology. The second big idea of the literature is differences between active and passive learning pedagogies within college-level science courses, in which the overall literature supports that students were often disengaged and not retaining information from passive lectures. Back to the brain's design, it was studied that you can only passively retain a few minutes worth of lecture before it gets bored and focuses the mind elsewhere, which then our active learning pedagogies engage the students in methods of participation in exams, collaborative work, and the key aspect in developing stronger metacognitive skills or critical thinking skills. And the third main synthesis regarded the student evaluation of active learning pedagogies. Students did enjoy being engaged, they saw its potential, and they had a better sense of self-efficacy and understanding of the material. More so, it is to note that some students initially perceive passive lectures to be easier. In concept, it makes sense because you just have to listen, but with dense material such as science courses, the end result was active learning led to better results for the students, and the majority of them preferred it. So I conducted my initial research through observations of two science courses, a Chemistry 2 and a Biology 2 course, both in the early morning for a total of 3 lectures per course. My sample of study were mostly science major undergraduate students and the lecturer. What I observed was essentially the engagement of students within the class and how the instructor engaged those students. So overall, I analyzed the types of interactions within the class as well as the overall attentiveness of the class. And furthermore, for the interview, I selected a student within the biology class and a student within the chemistry class for a one-on-one interview. What I meant to get out from the interview was to see the perspective of these students on engagement of the class performance and difference between the chemistry and biology courses, providing their expert insight on which I could analyze the effectiveness of these teaching methodologies. So what I observed was that between the biology and chemistry courses, biology had an average of 8.33 interactions within the 50-minute lecture, and chemistry had an average of 18.33 interactions per an 80-minute lecture. So despite the differences in the length of the lecture, chemistry course had almost double the amount, or more than double the amount of interactions, and the type of interaction was more focused on applications of problem solving, in which it was overall observed as an active learning pedagogy course, whereas biology was a traditional passive listening pedagogy course. So what I found from the interviews overall was that the interviewees both gravitated towards the more engaging course, which for the both of them was the chemistry course. Now initially I was researching the effects of time period of these courses, but here this led to a pivot in my studies. I found that they were more focused and attentive, preferring the more engaging class, regardless of the time of day, compared to when they lose interest and have difficulty focusing during the passive lecture. Now in regards to the depths of my research, both primary and secondary, the first interviewee describes how engagement within the class activates specific areas within the brain, which is important to understanding and retaining information, as the brain is more suited to learn these hands-on type environments. The interviewee also describes the energy of the chemistry course being more enthusiastic and collaborative, mostly due to the nature of the course, which assists in the retention as well as the overall participation within the course. And continuing, what was observed was more than double the amount of interactions within the chemistry course, more problem-solving, partner working, and trial-and-error type learning, in which the students had to think and process the new material with their prior knowledge and work problems out. Now, the biology course was found by both interviews to be less interesting and less engaging, which made them more tired and lazy for the course. That ties into how the brain works, in which that the emotional response of being bored or not really interested as you are sitting down and just having to listen to someone talk for over an hour will likely lead to very little retention or understanding of the material, whereas active learning develops understanding and processing of the material and essentially keeps the student involved because you can't really get bored if you're working. The overall end result of the active learning pedagogy is seemingly benefits such as enhanced thinking skills and positive evaluations within most studies. Among the students interviewed, both had positive appraisals toward the more engaging course. Interviewee 2 discussed how, though there was more work and struggling with an active learning pedagogy class, overall these students will do better in the long run retaining this information, going on to suggest benefits when taking big exams such as the MCAT or DAT. This holds true to other studies which support that active learning pedagogies led to a greater conceptual understanding in which the critical thinking capabilities developed allowed them to actually learn the material such that they retain and have enhanced learning for the longer and for the better. As such, what is to be concluded from my research is that an active learning pedagogy is more effective in regards to promoting student engagement and resulting increases in performances through the better developed understanding of material within college courses. The methodology for students to problem solve, work questions out, and work amongst each other and struggle while doing so is effective in the long run for their actual learning of the material. Now, what can be further implied with this information is future study regarding how a more active learning methodology can be integrated within these courses, and what can we do to increase engagement and change the passive lectures to adopt more active practices. These effective methods can be developed through experimental testing groups to evaluate these pedagogies and performances of students throughout a semester, which can help support a transition in teaching away from passive traditional lectures. And finally, exploring the effectiveness of the pedagogy on other courses, beyond just science, to gather insight as to how active learning impacts students, from mathematics to business or whatever it may be, but just to see if its effects in the long run and what it does to an individual's understanding of the material, which is important for their life in the future. Thank you very much.